Welcome to Housiverse, where we investigate the miracles of our regular world. I'm your aide, and today, we'll plunge into the captivating variations of desert plants. These versatile life forms have developed brilliant methodologies to make do in cruel desert conditions. Sorts of desert plants, desert flora. These notorious plants have adjusted to monitor water by putting away it in their thick, plump stems. Their spines diminish water misfortune and safeguard them from herbivores. Succulents, similar to the agave and aloe vera, store water in their leaves. Their waxy coatings forestall vanishing, salt bushes. These solid bushes flourish in saline soils, separating water from pungent ground through specific root structures. Water-saving systems leaf adjustments. Desert plants frequently have diminished leaves or changed leaf shapes to limit water misfortune. In the harsh and unforgiving environment of the desert, water is a precious commodity. Plants have evolved remarkable adaptations to survive in these arid conditions. One of the most fascinating adaptations is the modification of their leaves. By reducing the size of their leaves or altering their shapes, desert plants can significantly minimize water loss. This is crucial for their survival, as every drop of water counts in such a dry habitat. The smaller or differently shaped leaves have less surface area, which means there is less area for water to evaporate from. This adaptation helps the plants retain as much moisture as possible, ensuring they can endure the long periods of drought that are common in desert regions. A few even shed leaves during outrageous dry seasons. This might seem counterintuitive, but it is a highly effective strategy. By shedding their leaves, these plants reduce the amount of water they need to sustain themselves. Leaves are the primary sites of photosynthesis, but they are also where most water loss occurs through a process called transpiration. During extreme droughts, when water is incredibly scarce, shedding leaves allows the plants to conserve water and survive until conditions improve. This temporary loss of leaves does not mean the plant is dying. Rather, it is a survival mechanism that allows the plant to endure the harshest conditions. Once the drought passes and water becomes more available, these plants can regrow their leaves and resume normal photosynthetic activities. Profound roots. Their broad root foundations venture profound into the dirt, taking advantage of stowed-away water holds. Another remarkable adaptation of desert plants is their extensive root systems. These roots can extend deep into the soil, reaching water reserves that are not accessible to other plants. This allows desert plants to tap into hidden sources of moisture, ensuring they have a steady supply of water even during prolonged dry periods. The depth and spread of these root systems can vary greatly among different species, but the common goal is to maximize water uptake. Some desert plants have roots that can reach several meters deep, while others have a more widespread network of shallow roots that can quickly absorb any available moisture from light rains. This adaptability in root structure is a key factor in the survival of desert plants. CAM photosynthesis. Many desert plants use crassulacean corrosive digestion CAM photosynthesis, opening their stomata around evening time to lessen water misfortune during the burning day. CAM photosynthesis is a unique adaptation that allows desert plants to photosynthesize efficiently while minimizing water loss. In most plants, stomata, the tiny openings on the leaves, open during the day to allow for gas exchange, taking in carbon dioxide and releasing oxygen. However, this also leads to significant water loss through transpiration. Desert plants that use CAM photosynthesis have a different approach. They open their stomata at night when temperatures are cooler and humidity is higher, reducing the amount of water lost. During the night, they take in carbon dioxide and store it in the form of an acid. Then, during the day, when the stomata are closed, they use this stored carbon dioxide to perform photosynthesis. This adaptation is incredibly efficient and allows these plants to thrive in environments where water is scarce. The ability to photosynthesize at night and conserve water during the day is a testament to the incredible resilience and adaptability of desert plants. In conclusion, desert plants have developed a range of fascinating adaptations to survive in some of the harshest environments on Earth. From modifying their leaves to shedding them during extreme droughts, from developing deep and extensive root systems to utilizing CAM photosynthesis, these plants have evolved strategies that allow them to conserve water and endure prolonged periods of dryness. These adaptations are not just survival mechanisms, they are a testament to the incredible ingenuity of nature. By understanding these adaptations, we can gain a greater appreciation for the resilience of desert plants and the delicate balance of ecosystems in arid regions. As we face increasing challenges related to climate change and water scarcity, the lessons we learn from these remarkable plants can inspire new approaches to water conservation and sustainable living. The story of desert plants is a story of survival, adaptation, and the relentless pursuit of life in the face of adversity. It is a story that reminds us of the importance of preserving our natural world and the incredible diversity of life it supports. Let's delve into how some desert plants resist the scorching heat. Intelligent surfaces are a key adaptation here. Silver dark leaves, for instance, reflect the harsh daylight, significantly reducing heat absorption. Additionally, trichomes, which are tiny hair-like structures on the leaves, provide shade and reduce water loss. And interestingly, some desert flowers have adapted to bloom at nighttime, a strategy to avoid the daytime heat stress. Desert plants are true survivors, adapting to extreme conditions with remarkable resilience. Next time you encounter a cactus or a saltbush, remember their incredible journey of adaptation in the arid deserts.